Hi, what you're about to see is one of a series of short films from Tier 3 Solutions in which we outline ideas, principles or techniques which are bread and butter to us but may not be so familiar to everyone. We'll take the opportunity to answer some frequently asked questions too. The films should be a bit like the grey boxes you sometimes find at the side of magazine or journal articles that explain some of the background to a thing without interrupting the flow. If there's a specific topic or question you'd like to jump to, you may be able to find it in the timeline across the bottom of the frame.
To know more about animals' exposure to plant protection products in farmland, we often want to follow individuals. We might want to improve our chances of seeing what they're doing or what they're eating. Or we might want to know how much of their time they're spending in crops rather than in hedges or woodlands. Or perhaps we simply want to check which individuals are alive and present in our study area. We can achieve some of these aims by simply catching animals and putting visible marks on them. A collar or ear tag, for example. Some species, though, are very good at removing these marks from themselves or each other. Some animals are mainly active at night and so difficult to see. Some are small and fast-moving. Some are very shy, and if human observers are nearby, won't do what they otherwise would do. Still others are often visible, perhaps in large numbers, so we know where flocks or groups of them are, but following individuals is much harder. Often they all look very alike. Radio tracking and telemetry can help us with many of these problems. In this film, we'll explore some of the ways Tier 3 uses these techniques to inform risk assessments for agricultural plant protection products, for mammals and birds. Our most used tracking devices are these: passive integrated transponders, or PIT tags for short. These tags use technology found in contactless payment cards and in the security tags attached to goods in shops to deter theft. They come encapsulated in credit cards and security passes, in plastic tags for goods, or in sterile glass capsules about the size and shape of a grain of rice. This type is often fitted to pets, so that they can always be uniquely identified. We use them as a safe and humane way to permanently mark and identify the thousands of small mammals we may catch in the course of a long-term population monitoring study. Collars or ear tags may be chewed by small mammals, and some fight and can tear out ear tags. We can use patches of fur clipped from different areas to mark individuals, but the fur regrows, so these marks can only be temporary. Pit tags, fitted under the skin, do no more harm than ear tags, but they can't be damaged by the animals carrying them, or by others. Passive integrated transponders, as the name suggests, have no batteries or power supply. Instead, readers transmit an electromagnetic field from an antenna. When a transponder moves through the field, a current is induced in a tiny coil in the transponder, which then uses that current to transmit its own unique identity code, which is then read by the reader. When we catch an animal, we check it for a pit tag using a reader. No two pit tags have the same number, so there's no possibility of mixing animals up. We know exactly who's who.
First I'm checking for a mark, a pit, so this is a recapture.
As well as this ability to be sure of an animal's identity when we recapture it, we can use automatic pit tag readers to monitor animals when we're not around. To do this, we set up multiplex readers. Each reader module has 4 tubular coil antennas, which we can place in holes or runs where the tagged animals are likely to pass through. Of course, these multiplex readers may not detect all the tagged animals at a site, because perhaps not every individual chooses to pass through one of the runs or tunnels that has a reader. The readers also can't tell us anything about the animals they detect, other than that they were moving, and so, presumably, alive. But they can give information about individuals' presence and survival at a site over a long period, in return for relatively little effort in the field. The range of a pit tag is only a few centimetres though. If we can't get that close to an animal, or if we want to follow it over a distance, we may use VHF radio tracking. You probably have a VHF FM radio in your car. VHF, or very high frequency radio, is the technology we use for broadcast radio and for communications, such as marine and aviation radio. The transmitters we use to locate animals transmit VHF radio signals, just like the BBC, but at lower power. We have them built as collars for mammals, or backpacks, or tail mounts for birds, or they can be attached to leg rings for larger birds. The size, weight and shape are carefully chosen for each species, to be as small and unencumbering as possible. There's no point in studying an animal's behaviour if that behaviour is affected by the very method we're using to study it. The smallest tags, under a gram in weight, are for shrews and small birds. Typically, these can be received from a few hundred metres away, and might have a working life of a few days to a couple of weeks. Rabbits and hares, or pigeons say, can carry much bigger tags. These can run for months to years, and could have a range of several kilometres. We can determine the location of an animal wearing a radio tag using a sensitive receiver, which, unlike your car radio, can also tell us precisely the strength of the signal it's receiving. And we use a directional antenna, which functions a bit like a TV aerial. As we swing the antenna in an arc, we can quickly determine the direction from which the signal is strongest. The signal strength may also give us an idea of how far away the animal is. Perhaps we can see it if we look in what we now know is the right direction. Or we may need to move to a different location and try again. Then we can begin to triangulate the animal's likely position. Speed and accuracy come with practice, and a knowledge of a species' typical behaviour, and the habitat, and how different environments affect the radio signal. With experience, 1 or 2 biologists can usually keep up with a small bird or mammal on foot, and record where it is pretty much continuously. Over a few days, we often begin to learn where an animal likes to spend its time, and we can quickly track it to one of its usual haunts, where we can observe it visually and get details of exactly what it's doing. VHF tags usually transmit pulses or beeps. This makes them much easier to hear and saves power because the transmitter isn't transmitting constantly. We can specify the pulse's width and interval to choose a good compromise between tag life and range, and how quick and easy it will be to track in the field. A fast-moving animal will be difficult to track if its tag's pulses are infrequent. But for a species which rarely moves very far or very fast, a slow rate of pulses would be fine and save power, extending the battery life. We can also use the pulse width or interval to encode information. We can have the tag sense the animal's temperature and modulate the pulses in response, so that we can tell from the signal we're getting if it's hot and active or cool, and so perhaps hibernating. Or the tag might contain an activity sensor and send out faster pulses to indicate that the tag has come off, or that the animal wearing it hasn't moved for a while and might have died. This can be very useful to help us retrieve drop tags or dead animals. What about GPS? Surely we can use the technology we all have in our car sat-navs and phones to locate animals? Yes, we can, although there are limitations imposed by the battery power needed to receive signals from GPS satellites and to calculate a position from them. These factors limit the tags to being useful for larger animals, such as rabbits or geese, or for only short-term or intermittent use on smaller animals. The GPS tags used to track migratory birds, for example, might record only one location per day, and be asleep the rest of the time. This level of resolution is fine for monitoring transcontinental migration, but not so good for regulatory studies, where we might need several locations per hour, or one every minute. Unless we can be sure of recapturing a tagged animal, simply storing up locations on board a tag isn't much use. And often, it's difficult to catch animals at all, let alone recatching a specific individual. We've used these rabbit collars from Lotek for a number of studies. They combine a programmable VHF transmitter, a GPS receiver, and a VHF modem, all in one tag. We can pre-program the GPS, scheduling how often and for how long it will attempt to obtain a GPS fix. There's a trade-off between the frequency of fixes and the tag's battery life, and hence how many fixes we can get during that life. We can retrieve the fixes from the tag thanks to its VHF transmitter and modem. We can use conventional VHF tracking equipment to find and get close to the tagged animal. Once we are within range, we use a VHF modem to establish communication with the tag and have it send over all its GPS location data.
Perfect, we got it.
Rather than have the VHF transmitter and modem operating all the time, which would use lots of battery power, we can program the schedules for these too, so that they only operate when we know we'll be looking for the tag, say every Tuesday and Friday morning. Best of all, each time we communicate with the tag via its VHF modem, there's an opportunity to change the schedules for GPS and VHF transmitter and for the modem itself. So we can fine-tune the schedules as we go along, in response to events such as pesticide applications or changing day length. Radio tracking and telemetry provide us with various opportunities to obtain ever more detailed information about how animals move and how they behave. Advances in batteries, electronics and communications technologies are making it possible to collect data that just wasn't available a few years ago. At Tier 3, we keep abreast of the tech available so as to be able to inform agrochemical risk assessments with the best data possible.